Okay, my friends, what I'm about to talk to you about is just staggeringly essential for life. Enzymes, if you don't have them, you are going to die instantly, basically. They find enzymes that would take 2.3 billion years to do their work if it wasn't for the enzyme. And you know how fast the enzyme happens? Less than 1 second. It would take 2.3 billion years to do that chemistry. In 1 second, the enzyme does it. Without the enzyme, you're done. And guess where enzymes come from? Only from bacteria. And only one enzyme missing can cause you to be sick because that chemistry is not being done. All right, different catalysts, which are the enzymes, work at different speeds, but they found one that is so fast that the rate of production is increased by a staggering factor, one that's equivalent to the difference between the diameter of a bacteria cell, impossible to see, and the distance from the Earth to the sun. It's increased that many fold. These enzymes, it says it would take 2.3 billion years to do a half-life. And that's how these catalysts work. They work on breaking down things in half-lives. And all that chemistry could be done in 1 second with the correct enzyme. And he goes on and on about all these enzymes which we need to understand. And says we've only begun to understand how to speed up reactions with chemical catalysts. No one has ever come within shouting distance of producing or predicting the magnitude of their catalytic power. This is Wolfenden. And this was to the Academy of Sciences. They had a big thing about this, and they agreed, yes, these are amazing things, and they just left it at that. Enzymes do a prodigious job of catalysts, are hands down the most sensitive targets for drug development. All right, enzymes. But they're produced by bacteria. You cannot patent a bacteria, so they really don't do too much here. But the enzymes do a prodigious job. Enzymes are produced by bacteria. The most sensitive targets for drug development. Enzymes we study are fascinating because they exceed all other known enzymes in their power as catalysts. The amount of chemistry done in 1 second, it would take millions of years to do that same chemistry. You just fall over dead instantly without these enzymes, which means you need the bacteria to produce the enzymes. As simple as that. There it is right here. Without catalysts, there would be no life at all. None. From microbes to humans, none, zero, because they all use the enzymes. It makes you wonder how natural selection operated in such a way as to produce a protein that could do this kind of fabulous work. It got off the ground as a primitive catalyst for such an extraordinarily slow reaction. These reactions are very slow in nature, but when you throw that enzyme in, beep, done. I mean, done, and the enzyme doesn't get used up. It continues to be accessible to do its job over and over and over again. They don't get used. They're like little magnets, and that's what I call a click chemistry. They come way out like this, and they have all this magnetic signature. They go, and they just mow down everything in front of them that it clicks to this magnetism. It's like I'm being electrocuted. Millions, billions of them done just that fast. You know, they're asking about how life got off to the start. How could they create such elegant catalysts to make life happen? And without them, life does not happen. You don't have the enzymes, you don't have the life. That is bacteria. Bacteria is God's programmers. They're the programmers. They clean up the mess. They create the drugs. They're the pharmacists. They're the chemists. They clean things up. They can cause damage. Some of them go bad. Just like humans. You got your good ones, you got your bad ones. But they work fast. You know, you just feed them and they take care of you after that. But you can't assault them. You can't go in and kill them and then hope that the chemistry is going to happen all by itself. It doesn't without the bacteria. These are the things that grow in us. Bacteria. They are the factories of the enzymes. capable of producing a wide variety of enzymes. There's 75,000 that they know of, and there's probably more than that. And they include metabolism, digestion. The enzymes break down complex compounds instantly, as you will see or have seen. All right, I don't like to make unsubstantiated statements, and here it is right here. Bacteria are often referred to as enzyme factories. They are capable of producing a wide variety of enzymes essential for various biological processes, including their own metabolism. They have to make their own enzymes to make themselves grow well. But their main function in life is to do a couple different things. One is to create ribosomes. Ribosomes are just like this. They're a little tiny, 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 tiny ball, and 1,000,000 of them could fit in a single cell and still have room for everything else. But when they're called on, they do this. They explode into an enzyme. And that enzyme is so specific, it does literally millions of years worth of chemistry in less than 1 second. I showed you that stuff. I'm sure I did. And just look it up. I showed it. Now, if you don't have those, you're not going to get that job done. It's just not going to happen. So you're going to get weaker and weaker and sicker and sicker. Now, if you get pulsed with radiation, it wipes out basically a lot of the bacteria. Some deep inside bacteria maybe not get as damaged. Or if it's intense enough and for long enough, it'll penetrate everything, and you never recover. And you just die from radiation sickness. But the radiation sickness killed every enzyme in your body. I wonder if you had a fecal matter transplant instantly after getting high exposure to radiation, would you be better? Because you'd have all new bacteria. But you'd have to do it pretty quick. Because it happens within an hour. Within 1 hour of getting acute radiation syndrome, you can get really, really sick. And the sickness is digestion. You throw up. You have diarrhea. All kinds of gas and bloating and nausea and throwing up. And, your entire digestive system is destroyed. And if you don't have those enzymes, done. And you need them just continuously, 24/7. One right after the other, boom, 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 boom. They're very, very active, these bacteria, at creating these little products. You see, this bacteria can rapidly produce enzymes under specific conditions. That's the conditions of your body. And they have to be somewhat specific. You can't create bacteria that's going to do its job if it's dying inside of you. And a lot of it is. Because of the chemistry we have in our body and the things that we eat and drink and our lifestyle. Once you damage the bacteria that's in you, it does not produce the products you need. It does not do its job. It does not keep you healthy. It will not interfere as a protector. It will not create the immune system you need. It does not do its job of being in this fluid-filled highway, searching for invaders. It says, I'm too tired to do that, man. You're just not taking care of me. I'm not going to do it. And the next thing you know, you're sick. Okay, this is from a place called Easy Pro, Pond Products. They understand the cycle of what's going on. And they say this is how to, and understanding bacteria and enzymes. This is exactly what we want to understand. How do they work safely? What's the safety? This is a double-edged sword right here. Now I'm going to home in on this. This is the section we want to talk about. I say that the enzymes are the only thing that does chemistry in your body fast enough to make your body work, and the only thing that produces the enzymes are the bacteria. Enzymes are produced by bacteria. A big exclamation point. Microorganisms, like bacteria, grow and produce by eating available contaminants. They actually eat up the nasty stuff that's in your body. They produce enzymes that break down food so that the bacteria can digest it. Everything's a process of breaking things down. You can't eat a carrot and it becomes a mussel. Think of it this way. Bacteria can't digest the whole apple, so the bacteria creates enzymes. little chemistry sets, all right, to turn the apple into applesauce that they can digest. They got to crunch it all up, break it all into little bits and pieces. But we're going to break it into actual molecules, different molecules. Bacteria can reproduce very quickly, but enzymes cannot duplicate themselves. Once you create an enzyme, it just floats around in your body. It doesn't do anything at all. It doesn't poop. It doesn't eat. It's a free floater, and millions of them can fit in one cell. But when it's called on with a trigger, pow! It pops open to do its job. So they can reproduce very quickly, but they cannot duplicate themselves. They don't eat. They don't poop. They don't do anything. They have to be triggered to do their job. They're only produced by bacteria as a biochemical catalyst. So it's called a ribosome. It's a biochemical catalyst. Catalyst means enzyme. Here's the most exciting fact of all. There's hundreds of natural beneficial bacteria in nature. There's many, many, many thousands. Each one specializes in what they target to digest, and each one producing their own enzymes. Every bacteria has their own special chemistry set. And they don't overlap. I don't think. They may get close, but they don't overlap. Or they may overlap, but they're not identical. Let's go with that. All right, they specialize in what the target to digest is. What is a carbohydrate, a sugar, a fat, whatever. It doesn't have to work in an acid environment versus a salty environment. All kinds of things like this. Now, since the bacteria strains, that's the individual strain, it's an actual strain, a special set type of bacteria. It specializes in digesting toxins. All right, since the bacteria strains that specialize in digesting toxins and decomposing organic matter in lakes and ponds are already found in nature and are safe. They're there already. We need to use them. Producers can cultivate them safely and provide them as beneficial treatments to aid in water quality. This is a double-edged sword. They're available basically for free. You can grow them and just, ferment them and grow more and more of them. And they grow very quickly. They duplicate quickly. And they create, these are the things that create the enzymes. Problem is they're natural. And there's no money in it because you can't patent them. You can't patent a living creature. And these are living little creatures. So they do all the work that we need to have done. But there's not enough profit in it. So they don't do any research into it, basically. The only people that do the research into it are people making chemistry for pools and things like that to cut back on the bacteria and kill that stuff without causing other issues or whatever. But it has a whole other purpose. It should be looked at as our immune system, because it is our immune system. And it's only produced by bacteria. The bacteria live in a fluid-filled highway. If you don't have them, you're going to be sick. Okay, my friends, if you've been around, you know I've been running my mouth about enzymes and bacteria and how they affect the health, day-to-day health of everybody. You have to have those enzymes or you don't break down the products and you don't have the bacteria to fight back against invading bacteria. It's a give and take. There's good and bad, and you got both of them in you right now. Everybody has. But they cannot get overwhelmed. Well, so I've been studying the causal effects of missing bacteria. What happens when bacteria is missing? You're missing enzymes. What happens when you're missing enzymes? You're missing chemistry. If you're missing chemistry, what does that mean? Well, you can't provide either the products to build things or the products that break down things, which is to break down your food, to digest it. That's all done by bacteria. Or you can't create the proteins, which are the building blocks, the amino acids. Those are built by bacteria, and they build your body. Those are the building blocks that build your muscles and your bones, your eyeballs, and everything. So these bacteria are so important, it's incredible. And I sort of was, focused in on that so deeply that I was missing some of the other stuff. And I think I was missing something that this woman here is absolutely fabulous presentation up to the point I watched. And again, you're going to go through it with me. But she's starting off about cord blood. I really got to the point where I was working with the kids' digestive system. How do they digest? What is the stuff that's in them when they digest? Well, I wasn't thinking way back to the womb, other than the fact that, you know, what can you do? There's certain things that a woman should do, and be careful what she eats and make sure she has this and that. And that I don't have a whole good grasp on. But the other thing I didn't have a good grasp on was what she's calling cord clamping. And there's something called stem cells. We're going to look into that in a minute. But if you clamp the cord, she's claiming that you lose a lot of these earliest immunities that are built into the mother. Apparently. Now again, we're going to look at it together. I don't want to put words in her mouth. I'll let her state what she's going to state. But I found it extremely interesting that it may be a medical practice that is stopping the kid from getting these, you know, initial products of life through the umbilical cord. They clamp the cords. Now, she's claiming, well, let's just see what she says. But we really got to understand right from day one, right from conception, right before conception, you know, what's your body got to be like to be the correct environment, and how do you have to nurture that environment to make that product, which is the baby, you know, viable, strong, and healthy. And what has to happen immediately? And this woman here, she's got it. She's talking about the umbilical cord and the placenta and all of the, well, I'll let her say it. Again, I start babbling on about this, but it excites me. I got to be honest with you. When I find something new like this, which basically supports what I've been saying, but it gives it a whole new perspective and an addition to what I've been suspecting. And then she gets into the bacteria, into the ages of life, as I will show you. Again, I'll let her say it. All right, she's going to be talking about stem cells a lot. And it's because apparently the baby's supposed to get infused with them when they're being born. I'll let her discuss that. But stem cells are just like blank cells that can turn into basically anything. Their remarkable ability to self-renew, you know, they can, you know, continue to grow basically, and then they can differentiate into various specialized cell types in the body, just about anything, any tissue, and they are the body's repair system, tissue growth, repair, and replacement. So these are really important. Now, she claims that the baby's supposed to be getting them at birth, and when they cord clamp, they don't get them. Boy, I'll tell you, this is shocking. This is Dr. Suzanne Humphreys. The name of this particular video is Neonatal Immunity. That's the baby immunity system. The first 3 years, part 2. Now, she's only got 740 subscribers. This video is back 10 years ago to 2014, 2015, right in that area. And this is the best video I've seen yet. And I'm going to play it and we're going to listen to it together if you're interested. If not, well, that's up to you. But she's got information here that I didn't know about. Okay, my friends, I'm just going to play this. She's given a very, very good, you know, explanation of how a child's immunities grow even when before they're born, and especially as they're being born. Now, I have always worked from when they're born and they're starting to poop, And what is the poop like? Because that indicates what the digestive system is doing. However, there's certain things I didn't take into account. Now I'm going to have her speak here. And she's at a convention. This goes back 10 years ago. And this is about as good as I've ever seen. Now listen, here it goes.
Babies are built out of stem cells, which are crucial to the future of the baby's immune system and future life. Our longevity and our health is based in part on how many stem cells and the quality of them that we get at birth and how long they survive in the body. There was recently a study of a 115-year-old woman, and they looked to find out, she donated her body to science, and they found that she was still living on 2 lines of stem cells to make her blood. The placenta is a masterpiece of construction, orchestrated by stem cells and churning out millions of stem cells into every crevice and even into the amniotic fluid, where those stem cells orchestrate the lung and gut integrity.
All right, so we know that stem cells are just blank cells. They can turn basically into anything. However, I'm seeing that they got amniotic ones. They've got mesenchymal, or whatever that is. They've got epithelial cells. They've got Wharton's jelly. They've got hematological cells, and these are all apparently different stem cells, or maybe not. Let's see what she has to say.
In utero, the baby breathes, swallows, and urinates stem cells, as well as having them transported inside via the umbilical cord. There are about 80,000 stem cells in 2 mLs of amniotic fluid. However, at birth, the baby should receive a massive stem cell infusion from the cord blood. An immediately cord-clamped baby is deprived of its own property, which...
All right, what she's talking about is as soon as the babies are born, apparently the procedure was, and this is 2014, they clamp the umbilical cord so they just stop the blood flow. But she's still attached to the placenta. She's saying that they get 80,000, they had 880,000, but she's saying 80,000 of these cells. All right, so the umbilical cord, there are about 880,000 cells in only 2 milliliters.
However, at birth, the baby should receive a massive stem cell infusion from the cord blood. An immediately cord-clamped baby is deprived of its own property, which is approximately 8 million stem cells. The problem today is that many obstetric staff have lost their grasp of core physiology, so that even in 2014, hospital doctors and nurses often have never seen or done a delayed cord clamp. The function of these stem cells at birth is to dampen down the effect of the very high catecholamine stress hormones, which are actually vital to jump-starting that baby's immune system at the time of birth. The stem cells allow for a seamless transition in the baby for the next steps into life, one of which is the establishment of the gut and body microbiome, all those microbes. Profound anemia also results from immediate cord clamping. Up to 40% of that baby's blood can be left behind, and it's a contributor to much illness in infants today. Amazingly, even today, there are many in the obstetrics world who are uneducated and into thinking that a baby is in a privileged, sterile environment up until birth. This is what I was taught when I was doing obstetrics. But through DNA fingerprinting, we can tell that microbes are in the placenta, the amniotic fluid, the umbilical cord, and many other places, including meconium, which means that the baby has been exposed throughout pregnancy to microbes.
My take on that is the baby is getting enzymes from these microbes, and they're probably very, very good and necessary.
What we have here is meconium samples of 4 different individuals. This is an adult for comparison. This is a baby from a healthy mother. This is a baby from a mother who had gestational diabetes. This is a baby's meconium from a mother who had type 2 diabetes. And this is just the color coding of the different microbes. And what you can see is that they're very different from person to person, depending on, actually to group, depending on the status of the mother. One of the most important elements of a healthy child is a healthy microbe profile in the mother and the baby. And that's dependent on doctors understanding what normal really is and understanding what else they can do besides napalming the gut of the mother and tossing antibiotics into a situation when they don't need to be.
Exactly. We don't know what these bacterial levels should be at all now. We're just guessing. Like she said, throw some antibiotics in there, and it makes things worse.
The key for a mother and a baby is that the baby's immune system is about to be taught how not to respond, to develop tolerance over a period of time, so that it learns in a protected environment what's safe and what's not. And again, the key to this education of that baby is the mother. The maternal microbiome changes during labor, as I just mentioned, to become anti-inflammatory. Changes during gestation to be anti-inflammatory and then becomes inflammatory at labor. And then it changes during the feeding process, as I mentioned to you. So the baby is brought into anti-inflammatory after birth, where they'll stay for 2 years with that slow transition into a slightly pro-inflammatory profile. Mother's milk continues to maintain the baby anti-inflammatory, just like the placenta was.
What I've been asking for is to get the profile of what bacteria is coming out of the baby. You know, what's the poop like? That's what's going through the digestive system. Now, I would think she's going to get there. Let's see.
Antibiotics, antifungals, poor diet with low minerals, low fiber will put the mother-infant dyad at a disadvantage at any point before or during this period. This schematic here shows us the different colonization times of the infant based on its age. The major task of a baby's immune system is to know when not to respond. All of our immune systems right now are constantly sampling and screening material from within our own tissues and also from the exterior. And 99.99% of the time, it has to make the decision not to mount an immune response. A well-developed anti-inflammatory immune system is dependent upon microbial balance. Which bacteria dominate during the initial colonization process is very important, as is the stepwise introduction taking place at the right times. And we can see the shifts of the different bacteria that come in later. Whether or not the colonization process happened on time and appropriately can impact allergies, inflammatory bowel disease, autoimmune disease, and brain function. This is well documented in the medical literature. There are 3 classes of bacteria. One are called commensals, which you're probably familiar with. They're residents of the bowel and the body that don't cause any harm, but they don't really help. Then there are other ones called symbionts, which are residents that actually give benefit. And then there are microbes called pathobionts. They're residents that can cause disease under certain circumstances. For instance, Clostridium bacteria are actually very beneficial. We need them. But if we throw antibiotic into the system, what happens is their competitors are decreased, and then they can overgrow, and then they become problematic. That's an example of a pathobiont. But note that all of these bacteria are residents, normal residents, and that balance is the key. This one here, Bacteroides, is a symbiont, meaning that it gives benefit and it helps keep inflammation down. And as you can see, it's one of the first colonizers of that baby. So not only do antibiotics affect this pattern, but any kind of repetitive and constant stress or vaccination and the mode of delivery and even the mode of feeding can affect how this happens. Until relatively recently, it was assumed that microbes in human milk were contaminants from the mother's skin and that human milk was sterile. But when they collected milk under aseptic techniques, bacteria were still found. So scientists were mystified and they decided to look at the microbial DNA fingerprint and were astonished to find that human milk bacteria had different DNA fingerprints when compared to that mother's skin bacteria. A vaginally born baby gets its first gut flora bolus transplant from its mother's vaginal flora, which is hugely complex. And this is flushed down into the gut by pre-colostrum, clear fluid, and then that's followed by colostrum bolus, and then ends up in mature milk, which still continues to have microbes in it. There are approximately 10,000 bacteria per ml in aseptically collected human milk. But that's only part of the story. The milk that looks like a white liquid is actually a live transplant made from the mother's own blood. Human milk is a pulsing living organism which has one main function outside of food, and that is to keep everything in the baby as much as possible anti-inflammatory. Breast milk has substances which stop pathogens attaching and other substances which go after invading pathogens and butcher them to pieces. Development of the intestines and mucosal immunity and growth of many of that infant's tissues are mediated by human milk. That master butcher that I mentioned before is called Hamlet. It stands for human alpha lactalbumin made lethal to tumors. It kills tumors. It's being used by the oncology industry, or they're attempting to anyway, to treat cancer. But it happens to also be lethal to pneumococcus and encapsulated bacteria. Now, if you think this is a long list here of what's in milk, look at stem cells, microRNA, messenger RNA, we've got erythropoietin making blood, we've got factors that make bone and orchestrate bone, we've got food for the baby, we've got food for the microbes, there's all kinds of stuff going on there. But this is actually a really short list, because every time scientists look with new technology, not only does the list grow longer, but they find multiple functions for many components of milk that were formerly assumed to have had single functions. And Hamlet is a really good example of a protein that can be either a food or a killer. And we used to think that proteins only had one function, but it turns out that dependent on the shape of Hamlet, it's either going to become a killer or it will be a protein food. A mother's breast milk is unique to her baby, meaning that if she has a
See, that's something I didn't know. If that's true, the same molecule, but the shape, I know they have all different shapes. Of that I'm totally aware, but that I was not aware of. Let's go back and listen to that again. I see they were formerly thought to have a single function. That's what I have been working under, that assumption. All right, so she's saying there's all kinds of things going on. Now listen.
Because every time scientists look with new technology, not only does the list grow longer, but they find multiple functions for many components of milk that were formerly assumed to have had single functions. And
all right, well, listen to this now. Hamlet is supposed to be an enzyme, I guess.
Hamlet is a really good example of a protein that can be either a food or a killer.
All right, so I know that enzymes break things down, and proteins build things up, and that's exactly what she's talking about here. The killer is an enzyme. The food is the oh boy, I'm losing it. The killer is the enzyme. The protein is the food. So it's just an example. It can be a protein, can be either one. Now, I always assumed it was two different types of bacteria creating two different types of ribosomes. But she's saying it can be the same thing. That's a new one on me. Hold on.
And we used to think that proteins only had one function, but it turns out that dependent on the shape of Hamlet, it's either going to become a killer or it will be a protein food.
All right, so Hamlet, I would consider that two different strains. If it's one or the other, I can't see it being, well, anyway, who knows?
A mother's breast milk is unique to her baby, meaning that if she has a premature baby, she's going to make milk that's good for that premature baby's brain and immune system, and it changes to suit that baby, and it even changes throughout the course of a day, believe it or not. It does way more than flex a muscle. It's pretty much a miracle in the making, yet many mothers don't know that. But how could they, when scientists are only just beginning to understand the functions? But one thing that's becoming blindingly obvious to scientists and anyone who reads breast milk medical papers is that human milk contains factors that are capable of programming the infant's developing immune system and metabolism into a health-promoting model.
See, you know, my kids didn't have breast milk. My wife used formula, you know, and I don't know how good the formula is, but she's saying this breast milk has all kinds of things that I would be surprised if they have it in formula, but who knows.
Yet it does way more than that. It can heal and it can rebuild. I've got papers showing that a wet nurse without a disease actually cured a genetic disease in a baby that was suckling from her. That's because of the messenger RNA and the microRNA. Trying to remember the author's name offhand.
Wow, that's amazing.
I'll tell you. Remember that placenta that I showed you before? Well, IRMAK, I-R-M-A-K. Scientists who understand how placenta builds a baby, particularly when it comes to microRNA and messenger RNA, realize that breast milk performs many of the same functions as the placenta did in pregnancy. So, one big key to a baby's genetic destiny is the fact that a new mother's mammary glands take over from the placenta to provide the developmental guidance to ensure a baby's genetic.
Okay, I was watching this on CBS News, and these are 3 women that have children on autism spectrum. Just about everybody does now. Even the guy they're holding down in El Salvador, his son is on the autism spectrum, the one they took illegally. Now, these 3 women here are mothers of autistic kids. They're presenting this as, well, it's a challenge, but it's rewarding to live with these issues. And, you know, you could see it as, I see everything as a challenge too. And I see everything as trying to fix something or trying to improve something. That's the way my mind works. And apparently that's the way they work too. I would rather not have to go through that. And if there is a way out of this through testing and, you know, these fecal tests and all these things I've been talking about, you wouldn't have these people having to write books about this. All right, this just popped up, so I ran over to get a clip of it. And here it comes. You ready?
Twinson, Carriello, and Adrienne Wood are moms from different parts of the country who met on social media 6 years ago now, but they bonded over shared experiences raising their 3 sons who have autism. Kate is mom to 14-year-old Cooper, Carrie is mom to 20-year-old Jack, and Adrienne is mom to 11-year-old Amos.
All right, these are ones on autism spectrum, and they're trying to show that you can deal with this in a loving manner and still, you know, see it as like a challenge almost. That's the way I'm taking it. I'd like to get away from having to deal with it. So that's what this whole video has been about.